Okay, hello friends. Uh, I would like to show this, make this video because I was like kind of connecting the geometry to sequences and then also to graphics. So this is, the topic is on sequences, so how the recursive definition and explicit formula, the AND term is connected to this geometry. So this is about creating a sequence. You can see the maximum number of regions of a circle divided by lines. The first one, if you see, if you don't draw any line, you can see there's only one region here. So that's why when n is 0, it's 1. In the second one, I use purple color to show one line crosses the circle and divides this into 2, 1 and 2. So the answer is 2 regions. Then there is a third one. If there are 2 lines they cross, how many maximum number of lines, number of regions that you can see? It's like 1, 2, 3 and 4. So if n is 2, then I use because I use the orange color, so that's 4 regions. If there are 3 lines, so those are the 2, the purple and the orange stays the same. The additional one I did was the blue one, and you can see it breaks the maximum number of regions is 1, 2, 3, 4, 5, 6 and 7. There you go, 7. Then I added another line to the green one. So when I draw the green line, and then you can count them. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So if n is 4 lines, then the answer is 11. And after that, I added another line, that is the red one. You can see the red line 5 is added. So let's count how many of them are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So there are 16 lines. And then you can do one more there. I can draw one last one with the black color. So there are 6 lines. I want to make sure I can draw this passing through all the 5 lines. So I can draw this way. Okay, and then if I break this, you will see that if we count, it's going to be 22. Now the question is, what's the relation between this? How do I write this in the recursive definition? That's why. And clearly you can see that this one is 1 plus 1 is 2. So 2 plus 2 is 4. 4 plus 3 is 7. That means the one before. So each of this number is always at any time the number of regions. So this 7 is the one. So let's put it. So this one is this one plus 1. This 4 is plus 2. The previous one plus 2. This 7 is plus 3. So what's happening is you are adding. So here you add 4 plus 4, which is the same n. So this, if you are adding 1, it means your n is 1, the same one. If it is 2, n is 2 plus 2. If it is 3, the previous one plus the step number. So basically the next one, how do you get 16 is the previous one 11, it's like 11 and plus the 5, because 11 to 16 is 5, so plus 5. So if it is 6, so this is the previous one is 16 and plus, and the difference is 6, and you can see there is 6 difference, so 6, and you get. So how do we write the explicit formula is that the number of regions, this is the number of regions is the one before r of n minus 1 and plus the step number, whatever that is. So this is the recursive definition, and for n greater than or equal to 1, because in the beginning it is when you don't draw no line, there is one region. So for r0 is 1, and for 2 greater than equal to will be the rest of the sequence. How do we write the explicit formula? So that's my main focus here is how do we write the explicit formula Rn without the previous one Rn. Now let's see how it works. So this 2 is this 2. How did we get this 2 is it's 1 plus this 1. How did we get this 4? It's this 1 plus 1 plus 1 plus this 2. How did we get this 7? It's because the one before, that is 4, it was 1 plus 2 and then plus this 3. How do we get this 11? So it is 1, this whole thing 1 plus 2 plus 3 and then you add 4, this 4, so plus 4. How did we get 16? This whole thing 1 plus 2 plus 3 plus 4 and then you're adding 5 plus 4. And you see the pattern there. Now let's see this one. So this is R5. So when I write R5, that's 1 plus 2 plus 3 plus 4 plus 5. So if I write R6, that is going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6. And you can see there's a nice pattern here. So we do know the answer for this. If you want to add n number of terms, 1, 2, 3, 4, 5, 6, that is same as 6, whatever the number, 6, and 6 plus 1 divided by 2. Now this we can, in general, we can generalize and say Rn equals, it's 1 plus, so whatever that n, and it is n plus 1 divided by 2. Okay, now I want to create a, with this, I want to create a quadratic function from this. Can we do that? So now, because there's a 2, I can write this as Rn is, this one I can write 2 over 2 plus n into n plus 1 divided by 2. So now you have the same denominators. I can take half outside and write this as 1 plus, at the same time use the distributive property n squared plus n. And there you go. So finally you got a nice explicit formula Rn equals half. We can write this also as n squared plus n plus 1. See, and you're done. So this is quadratic function. So trying to connect the sequences, connecting geometry to sequences, and the sequences can be written 2 different ways. One is the recursive definition, and you can also write in the explicit formula, this one. You can also use Desmos and check Desmos.com, go to regression line and plot this data points, and once you, so you get one this way, and you see it's going to be a nice parabola like this. You can create the equation in the regression line by writing y1 this way, x1. So when you do this, you get the answers for A, B, C. So you'll see it is 0.5 x1 squared plus 0.5 xn plus 1, which is the same thing, this and this is the same thing. I hope this makes sense. I'm ending this video by just wanted to see how nice it is to see the maximum number of regions that lines can split the circle connects to sequence of numbers, and that sequence we can write in 2 different ways, is recursive definition and the explicit formula, and we can graph. And if you had to put this data plots in the regression line in Desmos.com also, you get the same answer. So beautiful is how can we model mathematics, can be modeled from this geometry. Hope that helps. Thank you so much for watching the video.